All right, you guys, this is a question that came in from homework 64. So your sphere homework again. I just made another video about this sphere. So I had brought in some materials, some models for you. So here is just a glass of water. I have it filled about halfway, just like the problem is saying. And I have a sphere right here. So I have a golf ball, okay? So just to help you visualize what's happening here. So let me just read the problem really quickly. We have a cylinder-shaped tank with a diameter of 20 inches. It is half filled with water. How much will the water level rise? That's what I'm looking for. What would be the height here? How would it rise once we place a metallic ball? So, placeholder here, golf ball, with a radius of 4 inches in the tank. So these are good visualizations. So I'm going to drop this into my water glass like that. And I'm looking at how much did that water level rise after I dunked it into my glass of water. Okay, so let me do my split screen and show you how to work it. Okay, so here we go. So here is my problem again. I have this cylindrical tank, so it's shaped like a cylinder. Diameter is 20 inches, so let me label that. So diameter is 20 inches, which means that a radius here to here would have to be 10 inches. Okay, it is half filled with water, so right now it's right about here. Okay, and then how much will the water level rise in the tank once you place a metallic ball with radius of 4 inches in the tank? So we're looking at how much does it rise? So I essentially am starting off right here. So this highlighted portion, that's my pre-existing water, right? I dunked in my golf ball and that water level rose right here. So I'm trying to figure out, how did that volume of the sphere make the water level rise in my cylinder right here? So I want to figure out, well, what was the volume of the sphere? So volume of the sphere. We know that that's 4/3 pi r cubed. So right now I know that it has a radius of 4. So I'm plugging in a 4 right here. So I'm taking 4/3, 4 cubed is 64. So 4/3 of 64 pi. So if I take 4/3, multiply it by 64, I'm going to get 256 over 3 pi. Or I could also write that as 85 1/3 pi, right? They're both the same. We're just talking units cubed, and we're talking inches then cubed. All right, so I know the volume of the sphere, but I actually don't know the volume of the cylinder, right? I actually don't know, and I'm trying to figure out, really, this cylinder is what I'm focusing on right in here. Let me draw that out. So I want the volume of the cylinder, and I want the one that's in green. I want this right here. Okay, so there's that green little tier right there, which is the rising level of my water. So here I know that my radius is 10, and my height, I'm just going to go ahead and call that h. So here I'm looking at my cylinder would be base area times height, so pi r squared times the height. I know that my radius is 10, but I don't know the height, right? That's what I'm trying to solve for. So I have 100 pi times the height, inches cubed. All right, so I have my two volumes, and I know that I should just set them equal to each other because I'm trying to find what is the height here? How much did that water level rise? So here I'm going to say that 256 pi over 3 is equal to 100 pi times the height. So I'm trying to get the h part all by itself. So I could divide each side by pi, and those pi's will divide away. So really, I have 256 over 3 is equal to 100 times the height. So I could just go ahead and divide each side by 100. or I could have multiplied each side by its reciprocal. That would have been fine as well. So I'm taking my 256/3 right there, and I'm going to divide that by 100, and I'm left with a height of 64/75. Oh, didn't mean to do that. So 64/75 as a decimal would be about 0.8533 inches. So let me just do a little recap. I'm trying to figure out how much the water level rose. I'm trying to solve for h, right? That's my height. How much did it rise? So I had my original water. I dropped in my golf ball to represent my sphere in the problem. So I know that the volume, that space that it occupies, it filled up this much. So I know that the volume of the sphere right now, this is what I'm just looking at in terms of a cylinder equivalent, right? The space, the total space that they fill up, that they occupy is the same. So I'm taking that volume of the sphere, the volume of the cylinder, setting them equal to each other, and then solving for that height right there. And I ended up with a 64/75, or about 0.855 inches. All right, I hope that makes sense. Have a wonderful rest of your day.